Hello, today we're going to go through some practice that we did in class, but this is just a refresher in case you were absent or wanted to watch it again. You will be asked to do something like this on your assessment, so it's good to know how to do this. We just have a couple examples here of constructing and then drawing things within the construction. This first one asks us to construct an equilateral triangle. If you remember how to do that from before, or if not, here's a refresher. You start with a line segment. They want my triangle to be ABC, so I'm going to mark these two endpoints A and B. And then you take your compass and you want to make 3 line segments that are the same size as your first one. It's an equilateral triangle. So you're going to set that distance like that. And I'm going to make my third point right up here. I might be outside of the square, but that's okay. Don't change the width and make another dash so that they meet. I'm going to meet right up there. That's where my next point is going to be. So you can go ahead and label it right away if you want. That's going to be point C. Take a straight edge and connect those. You should get 3 equal line segments. All right, so you've got an equilateral triangle right now. Awesome. Now, they want us to now construct a perpendicular bisector of AB. So that's this guy right here. So we want to make a line that goes through at the mid segment and hits at 90 degrees. So to do that, you take your compass and you're going to open it up so it's over halfway. As long as it's over halfway, you're good. And you're going to make an arc, and you want to make sure you swing that down to the bottom as well, just like that. Don't change the width. Go to the other side and make the same arc. You notice how they cross here and here? If I draw a line right through there, that will hit the equilateral triangle perpendicularly, or hit AB perpendicularly. I'm going to go ahead and just draw that. So I've got it lined up. Draw that right through there. It hits this line right here. Now they want us to know if it goes through point C. Yes, it does. Label the new line CD. So I'm going to make D right here, right where it hits AB. And this segment will be equal to this segment. That's what a perpendicular bisector does. All right, so we've got 2 triangles now, right? We've got ACD and we've got BCD, and you can kind of see those 2 line up right here. I'm going to put that right here. We've got ACD and BCD. What can you tell? Well, there's a lot of congruent pieces in this. First of all, line segment AD is going to be the same as line segment BD. So AD is congruent to BD. So they both have that same, is the same. Another one I see, because it's an equilateral triangle, AC is going to be congruent to BC. And this is kind of silly, but both of the triangles share this side, this CD. And CD is congruent to itself because it's the same line, right? So I'll put 3 in there just to show. So what we can say is we can say that CD of one triangle is congruent to CD of the other triangle because it's the same line. That's called the reflexive property. So with these 2 triangles, I can say that all 3 sides are the same. They have 3 congruent sides. Now let's look at the angles. It's equilateral. So in the beginning, this angle right here, CAD, is the same as CBD. These 2 angles are the same. So I can say that they're congruent. All right, so those 2 are congruent. Also, I've got another thing right here. This is a perpendicular bisector, right? So angle CDB is going to be the same right here as this one. These are both 90-degree angles on each triangle. So angle CDB is congruent to angle CDA. CDB is this one. CDA is this one. So those are the same. Well, and if two of the angles are the same, and all three of the angles have to add up to 180, that means that this third angle right here, it must be the same for each one of those. So angle, let's see, that'd be ACD is congruent to angle BCD. Wow, so everything's congruent. These two triangles are congruent triangles because every side is the same and every angle is the same. Very cool, very cool. Let's look at another one now. Again, an equilateral triangle, so I'm going to quickly go through the steps of making one of those. See how quick I can be. Equilateral, oops. AB, open that up. Hopefully by now you're getting pretty quick at this. Careful not to change the width. Ooh. All right. Connect those points. Call it C. Okay, not as pretty, but it's there. ABC. This time they ask us to do the angle bisector of angle A. So that's this angle right here. All right, so angle bisector. First, I need to take that and draw a arc through the two rays that make up the bisector, in this case line segments, or angle. So I draw that. It gives me two reference points. From there, I'm going to put my point right there and draw an arc. Do the same thing to the other side, keeping the same distance. That gives me a point through which I can make the bisector. And now I'm going to simply draw a line through. Just like that. All right. So angle bisector, by definition, tells me that this is equal to this, right? Those two angles are the same. All right. Does this go through point C? No, it doesn't. Label this. Okay, so this will be A, this will be D. Awesome. Again, I get two triangles, right? My first triangle, I'll say ACD, and then ABD. Awesome. So what do we know about these two triangles? Well, I know that these two angles are the same, so I know that angle CAD is congruent to angle BAD. I know that this line is congruent to itself, just like the previous one. So I know that line segment AD is congruent to line segment AD. I know that this side is congruent to that side because it's an equilateral triangle. So I know AB is congruent to AC. Now, I don't necessarily, at this point, we don't necessarily have the information to know if these two line segments are the same. So I can't really write that. I do know that those two angles are the same. Equilateral triangles have equal angular angle measurements. So I do know that angle ACD is congruent to angle ABD. Oops. So I do know that. So I know an angle and a side and another angle, or I know side, angle, side. That's all going to come to play a little bit later in the game. All right, I hope that this has been helpful.